Section 6.4, example 8, graphing a reflection of the logarithmic function y. Sketch a graph of f of x is equal to log of negative x alongside its parent function, include the key points, and asymptote on the graph. State the domain and range. Ooh, this one's going to be fun. So here we have our graph, our function. Without any shifts or translations, we're just getting rid of that negative sign. So for this, our function or our parent function is just going to be log of x. And our parent function p of x. And just as before, it's easiest to start with our outputs and then kind of go back into our inputs. So -1, 0, and 1. For this one, I'm just using 3 points as opposed to 5 because we would end up with the power of -2. And that would be, well, not just -2, but like 100. So inputting 100 is a lot more difficult. So here we're just going to go tens. So -1, here we don't have a base. So we say that our base is 10 when the base is not told. So 10 to the power of -1 is just going to be 1 over 10. Or we could do the decimal which is just going to be 1.0 or 0.1. 0. 10 to the power of 0 is 1. And lastly, 1. 10 to the power of 1 gives us 10. So those are our inputs and our outputs. All right, so from here, we're inputting 10. Let's shift this over. Make it a little bit easier for us to graph. So when we input 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Much better. So when we input 10, we output 1. When we input 1, we output 0. And when we input 1/10 or 0.1, we output -1. For logarithmic functions, we have a vertical asymptote. And here our vertical asymptote is just the line x equals 0. Again, because whatever we plug into here, it's always going to be greater than, or numbers greater than 0. So our asymptote, it's x equals 0. All right, so we have that. Now for our actual function f of x, that's log of -x. So all of our inputs we're multiplying by -1. Outputs are not going to change because we don't have anything influencing our graph outside of the function. So the input of 0.1 is now going to be a -0.1. The input of +1 is now going to be -1. And the input of +10 is now going to be -10. The outputs are not changing. So I'm going to regraph this so you guys could see it a little bit better. I'll be back. And I'm back. Okay, so here, as you could see in the previous graph, I didn't have any of this, which would have made it impossible for us to graph this. But now we have like an area where we could graph both of the functions, and that's perfect. So let's get started. So from negative 0.1 to -1. It's going to be really close to 0 here. And now when we input -1, we output 0. When we output -10, input -10, we output +1. So our graph does something like this. And our vertical asymptote is still the same. X equals 0. Because it is at x equals 0, we didn't move left or right. We just did a reflection about the line y or x equals 0 or the y-axis. Let's state the domain and range because this is kind of cool. Domain for this function is actually the opposite of what it is over here, because the opposite of 0 to infinity is going to be -infinity up to 0. So as far left as we could possibly go, which gives us that -infinity. And we stop right here. Well, we actually never stop. We get really, really, really close to 0, but never actually touch it. So that's our domain. Our range for logarithmic functions is always going to be all real numbers or from -infinity to infinity. And lastly, our asymptote. Our asymptote is going to come from whatever, when we set our inside equal to 0, and that's going to be our x equals 0. And that's it. Pretty cool, you ask me. If you have any questions whatsoever, please feel free to ask. Otherwise, bye.